Okay, today we'll be taking a look at some more rules for working with probability. Yesterday we kind of had an introduction to the simplistic rules of probability. We looked at classical probability and empirical probability and how we calculated those. Basically put, it was the number of times something occurred out of the total number of possible occurrences that we could have. And then we put it in the form of a percent to define a probability. Today we're going to look at working in situations where we may be talking about the probability of multiple events occurring, one or the other occurring, and we'll kind of call this the addition rules for probability. You can take out your note packet and follow along with the video. If you don't have a note packet, you can go ahead and get one real quickly. When we are looking at multiple events happening at one time, there are several ways to consider when we're talking about the probability, several things to take into consideration. The first thing we're going to need to consider is if the events can actually occur at the same time, or do they have to occur at separate times. If the events cannot occur at the same time, they're what we call mutually exclusive events. For instance, I cannot flip a coin and get a head and a tail at the same time. It's not possible. However, if I was flipping a coin and drawing a card out of a deck of cards, I could flip a head and draw, say, the King of Spades at the same time. So they would not be mutually exclusive events. So when we say that things can't happen at the same time, then they are what we call mutually exclusive, meaning that they're not going to have any outcomes in common. They don't happen at the same time. Let's look at an example here. Determine which events are mutually exclusive and which would not be. We'll kind of talk about them as we go. The first one will be rolling an odd number or rolling an even number, and this is talking about rolling a die. If we roll a die, what is the probability of rolling an odd number, or what is the probability of rolling an even number would be what we're looking at. And the question is, can those events happen at the same time? In other words, can I roll an odd number and an even number at the same occurrence? If I just roll one number, can it both be odd and even? And the answer is no. So that would mean that those are mutually exclusive events. They cannot happen at the same time. There is no number that I can roll on a die that is going to be both odd and even at the same time. Okay, let's look at another one. Getting an odd number and a number that is less than 4. Going back to the die again, if I'm rolling a die, can I roll a number that is both odd and less than 4 at the same time? In this case, yes, we can. There are numbers that you can probably imagine on a die that would be less than 4 and are odd. And hopefully you're thinking of the numbers 1 and 3 now. If not, I could roll a 1 or a 3 and they would both be less than 4 and be odd numbers. So these are not mutually exclusive events. They can happen at the same time. What about drawing from a deck of cards and drawing a card that is both a 7 and a jack? In other words, is there a card in a deck of cards that I can draw that is both a 7 and a jack at the same time? And the answer is no. So these would be mutually exclusive events. Mutually meaning working together, exclusive meaning that they don't overlap. There's no overlapping there. Getting a club and getting a king. Going back to the same deck of cards now. I'm going to draw a card. Can I get a card that is both a club and a king at the same time? In other words, can these events happen together? And in this case, the answer is yes, they can. So these are not mutually exclusive events. Now, what about the example of getting a king and an ace? In other words, can I draw a king and an ace at the same time? And I know some of you are not that familiar with your deck of cards, but hopefully you're looking at something that I've given you something on the board or something there. You are familiar with them enough to know that there is not a card that is both a king and an ace. So these are mutually exclusive events. You could not get a card that is both a king and an ace at the same time. So again, anytime we're talking about something being mutually exclusive, that would mean that the events cannot happen at the same time. And when we are talking about events that can happen at the same time, they are not mutually exclusive. Now, you're probably wondering, why the heck are we worried about all this? Well, it comes into play when we talk about something we call the addition rule. The addition rule is when we're talking about two or more events occurring at once. If the events are mutually exclusive, then we can use the formula that is given here. Probability that A or B occurs would be equal to the probability of A occurring plus the probability of B occurring. So say we wanted to go back and draw, or let's say we're rolling a die again, and we want to roll a number that is either that is either a 1, let's say, that is either 1, or we want to roll a 3. So we can get the probability of rolling a 1, which would be 1 out of 6, and the probability of rolling a 3, which would also be 1 out of 6. And we could add those two together, and of course the probability of getting a 1 or a 3 would be 2/6, which would simplify to 1/3. This is all taken into account that these events cannot happen at the same time. I can't roll a number that is both a 1 or a 3. So anytime we're talking about this event happening or the other happening, we must use what we call the addition rule. We just add their probabilities together. Let's look at another example here. We're going to roll a die with 6 sides. What is the probability of rolling a 3 or an even number? Okay, two different situations than we were just looking at, or I guess one different situation. What is the probability of rolling a 3 or an even number? Well, since these cannot happen at the same time, we can add the probabilities of them occurring. The probability of 3 occurring plus the probability of an even number occurring. Now, even numbers, of course, we're on a 6-sided die, so the even possible outcomes would be 2, 4, and 6. Out of the 6 possibilities, that would be 3 out of 6. And then, of course, we have our 3 there, and the probability of rolling a 3 would be 1 out of 6. So the probability of rolling a 3 or an even number would be 1/6 plus 3/6. And of course, I know we're not all great with fractions, but hopefully we know 1/6 plus 3/6 is 4/6. And you can see that's coming off the bottom of the screen. Hopefully you're okay with that and you can see what's going on there. Let me fix that here real quick. Okay, I slid it down just a little bit for you, and hopefully you can see that. 1/6 again plus 3/6 is equal to 4/6. So the probability of rolling a 3 or an even number on a die of 6 sides would be 4/6. Of course, that simplifies to 2/3, and we always want to simplify our fractions. Now, we also have to consider the addition rule when the events are not mutually exclusive. If the events are not mutually exclusive, they could happen at the same time. They're not necessarily guaranteed to happen at the same time, but there would be a possibility that they could. And in situations where they could happen at the same time, we have to take some things into account. The first thing that we would have to do is recognize the fact that they could happen at the same time. And then what we would have to do would be subtract out any events. After we add the two probabilities together, we would have to subtract out any events that might end up being double counted. In other words, I believe we talked yesterday about an example where we were looking at a deck of cards and talking about the probability of drawing I believe it was a 5 and a diamond. And we said that there were 4 5s, but there were also 13 diamonds. But that didn't mean that there were 17 cards that worked, because one of those cards was, or one of those 5s was a diamond. So we didn't want to double count it. So we had to counter out that by subtracting out one of those events. So that's basically what we're talking about here. And we'll look at some more examples as we go, but we have to subtract out anything that would be double counted. We don't want to count something twice as we're adding up all the probabilities. So the addition rule, if our events are not exclusive, would be starting off that we're going to add the two probabilities together just like we were before, the probability of A plus the probability of B, but we're also going to subtract out the probability that A and B happened at the same time. Because when we added them together the first time, we already counted that situation where they were both happening. So we don't want to count it twice when we count up the A's and the B's together. So we'll fix that by subtracting out the probability of A and B. Hopefully it'll make a little bit more sense when we look at this example. In a hospital, there are 13 employees, 8 nurses, and 5 doctors. 7 of the nurses and 3 of the doctors are female. So we have a situation, we got males and females at a hospital that work there, 13 employees, 8 are nurses, and 5 are doctors. Well, of course, you can have a nurse that is a male and a nurse that is a female. So those events can happen at the same time. Likewise with doctors. Not all doctors are males, not all doctors are females. So we could have both situations, and the situations are not mutually exclusive. So we want to know what is the probability of selecting a nurse or a male. Well, here's the breakdown based on the information given to us. 7 of the nurses and 3 of the doctors were females, so that would leave over 1 male nurse and 2 doctors that were, I wrote physicians, but obviously that's doctors, that are also male. 2 doctors are male, 3 females are doctors. So what is the probability of selecting a male or a nurse? Well, we have 13 people, and you can see of the 13 people, 3 of them are males. 2 of those 3 males are doctors, and 1 of them is a nurse. So what is the probability of getting a nurse or a male? Well, if we add up the nurses, we have 8 out of 13. If we add up the males, we have 3 out of 13, but we cannot add 8 13ths plus 3 13ths because we would be double counting the 1 male nurse. So what we have to do is we have to say the probability of a nurse plus the probability of a male minus the probability that we have a nurse and a male at the same time. So that would be 8 13ths plus 3 13ths minus 1 13th. And that would give us 10 13ths. Hopefully you're following that. Let's take a look at another example. Okay, here's an example that I've put together for you. Coach Hunt's Algebra 2 class has 25 students in it. There are 16 juniors and 9 seniors in the class. 7 of the juniors and 5 seniors are male. Again, this is a very similar problem to what we just saw. We have 7 juniors that are male and 5 seniors that are male. It told us that we had 16 total juniors, and since 7 of those were male, that would leave 9 of those being female. And since we had 9 seniors total, that would mean that since 5 of them were male, that we would have 4 females. Now, that's a breakdown of the class. Now, the question is, what is the probability of selecting the student that is a senior or a female? Okay, so I can pick any student, and any student that qualifies for us is either going to be a senior or a female. So if we don't pick a senior and we pick a female, we're still meeting the qualifications, and vice versa. However, there would be some students that are both seniors and females, so we have to be careful here. So what we're looking at, and I'll try and help you see a little bit more, when we're talking about seniors, we are talking about these 9 people. So that would be 9 out of 25 is the probability, 25 total students that we were talking about. 9 out of the 25 were seniors. But we also have, we could also pick a female. Well, out of our 25 students, these 13 here, we have 9 juniors and 4 seniors. So 13 out of 25 would be meeting the qualifications for females. So we don't want to just add those up and say 22 out of 25. That would be wrong. And the reason is because I have double counted some of these, and if you kind of look at what's been circled here, you can see that as I circled this group and I circled this group, we have a nice overlap right here at this 4. So we would want to make sure that we don't double count those 4. So what we're going to do is we're going to say 9/25, which is the probability that the student is a senior, and then we're going to add 13/25, which is the probability that the student is a female, and we're going to subtract the probability that we have a student that is both a female and a senior, and that would be the 4/25 that was right here where they overlapped. So that keeps us from counting it twice. See, as I counted up this 9 right here, my 4 students right here were counted once, and then when I counted up the 13, these same 4 students got counted. So we don't want to count them twice, so we're going to subtract them out once, and that would therefore make them get counted only once. So as we add this up, that's 9 plus 13 is 22 minus 4 is 18 out of 25 students that would be meeting the qualification of a senior or a female. Now, going by the formula, again, the probability that we have a senior or a female, as I gave you the formula before, is just what we had. The probability of a senior plus the probability of a female. And I'm going to erase that out of my way real quickly since it was wrong. And then we would, of course, subtract the probability of a senior and a female happening at the same time. So that happened 4 out of 25 times. So we had to take that out. Again, hopefully you're seeing this. If not, we'll continue to talk about it a little bit more in class. You do have an assignment that is listed in your note packet, and hopefully you can go ahead and begin working on that, and we can discuss it a little bit more in class.